The function f is defined. What is the x-coordinate of the point of inflection where the graph of f changes from concave down to concave up? So if we're talking about concavity and inflection points, then we need the second derivative. So let's take the first derivative of f. Derivative of sine is cosine. Derivative of cosine is negative sine. So take our second derivative. The derivative of cosine is negative sine. Derivative of sine is cosine. So we want to set that equal to 0. If we do that, it doesn't matter if you add the sine or if you add the cosine to the other side. So let's just add the cosine to the other side. So we're looking for where on the interval from 0 to 2 pi, where the sine and the cosine are equal to each other except they have opposite signs. So if you remember, sine and cosine are equal to each other in multiples of 45 degrees, or in radians, pi over 4. So pi over 4, they're the same. Right here at 3 pi over 4, the cosine is negative and the sine is positive. We want a negative sine and a positive cosine. In quadrant 3, they're the same again because they're both negative. In quadrant 4, at what's that, 7 pi over 4, then the cosine is positive and the sine is negative. So it looks like that's what we're looking at, and the angle that makes that true is the 7 pi over 4. That's the only point of inflection, so that means our answer choice is going to be D, and apparently that's not true. Both of these are where these have opposite signs. So we have 2 points of inflection, 3 pi over 4 and 7 pi over 4. So we need to know which of those points of inflection are a change from concave down to concave up. So we need our wiggle graph. Put these in order: 3 pi over 4, 7 pi over 4. This is f double prime. So in quadrant 1, as we go from 0 to 2 pi for our endpoints, in quadrant 1 and up to here in quadrant 2, cosine is positive, sine is negative. We can pick any value between 0 and 3 pi over 4, so let's just pick pi over 2. And if you substitute in pi over 2 into your second derivative, then you have sine pi over 2 minus cosine pi over 2. Cosine pi over 2 is 0, and sine pi over 2 is 1, and we have the negative. So we're talking about a negative right there. And then that means that f is concave down, right? So that's looking like this is the answer, which it is. Then we could pick something between 3 pi over 4 and 7 pi over 4, anything in between here. So let's pick pi. If we put pi in for sine, then we're going to get 0 there. And the cosine at pi is -1, so minus a -1 is a +1. So that means on this interval, everywhere on that interval, second derivative is positive, which means that f is concave up. And then we could go to our third interval here, but since we're changing from concave down to concave up, this is our inflection point right here at 3 pi over 4.